Alright, first question. Convert each of the following units. Be really handy to kind of remember how to get from kilometers to meters, centimeters. Okay, we're dealing with millimeters to centimeters, so from here to here. So usually it's just, what was this one? This one's divided by 10. So if we're dealing with square units, it's the same. Dividing by 10, but now because the units are squared, we need to square what we would usually divide it by. It's divided by 100 squared, 10 squared, which is 100. So you put in your calculator, divide this by 100, it should be 500. Next one, meters, cubic meters into cubic centimeters. So usually that would be 1 meter has 100. So this is the same. 100 cubed. That would be put that in your calculator. Okay, 4 times 100 cubed. 6.2 hectares. We should remember 1 hectare equals 10,000. So 6.2, we would just take 6.2 multiplied by 10,000. And we need to remember this 1 cubic meter is the same as 1 kiloliter, which is 1,000 liters. So did I do that right? Yeah. So this 1.2 is the same as times that by 1,000. And then to get to liters to milliliters, we need to times it by another 1,000. So find the area of the composite shape. Okay, 182. Total area. Area of the first part, A1, is a square. That's 30 times 30. Or you can just write 30 squared. Area 2 is a triangle, which is, remember, it's half times base times height. Calculator. So just put it on your calculator. Next part, shaded area. We have to do big area, big rectangle, take away big rectangle, take note that I'm not trying to do any shortcuts. I like laying out, structuring my working out like this. Just makes it clear for me. So if I'm looking back, I know what's happening. The big rectangle is 7 times 3. Take away the small rectangle, 5 times 1. Put it in your calculator. Next question. Find the area of the following shape. This is a parallelogram. Okay? 3.7 is from here to here. 29 is the perpendicular height. And they've drawn a triangle here for us, a right angle triangle, to indicate to us that this 29 is in fact the perpendicular height, not the slanted height, because the area formula for a parallelogram is the same as a rectangle. So you can use base times height or length times width, doesn't matter, breadth times width. There's different variations of it. area is 29 times 3.7. Square millimeters. Calculate the area of the regular hexagon is the next one. We're going to split up this into A1 and A2 again. These trapeziums are actually the same, so I really only have to find the area of one of them. I use my formula like this. Your variation might be a little bit different. Height over 2. The height is in fact 6 because 12 is the whole thing. So half of 6, or 6 divided by 2, A plus B, so 7 plus 14. Calculator, once again. Let the calculator do the hard work. 63, that's one of them. I almost was going to say that's it. Then we need to double, yeah, so A1 plus A2. So you can just times it by 2, same as adding it to itself. Length of a longer diagonal of a rhombus is that. If the area, what is the length? Cool. So, question wants us to work backwards. So draw your trapezium. The longer diagonal will be this one. I should have drawn dotted. So the longer one, from here to here, is, what is it? What did it say? 3.6. That's the whole thing. The other one we don't know. I know for a fact area is 5.4. I know for a fact diagonal 1. The question wants us to find diagonal 2. So I remember the equation of the area of a rhombus is area equals half times xy. In this case I use D1 and D2 though. Area, I know area for a fact is 5.4. So I'm going to fill in the rest. Diagonal 1 is 3.6 times diagonal 2. So half times 3.6 times something equals 5.4. We can play the guess, trial and error game. That's going to take us a while. We can in fact do half times 3.6. You put that in your calculator, you get 1.8. 1.8 times the second diagonal would equal 5.4. So if we want to find what the diagonal is, we do 5.4 divided by, that's the opposite of multiplying. It's like when we solve equations. This times something is D2. Sorry, this times D2 is this. So to find D2, we'd have to do this divided by that. It's just working backwards, and you should get D equals 3. And if you are unsure or paranoid that, did I do something wrong, that's fine. Put it back into the formula. Area, pretend like you're finding the answer now. Area of the rhombus should be half times 3.6, because that's diagonal 1, times 3. Put it in your calculator, you will get 5.4. And if you don't, you know you did it wrong, because the question tells you that you should get 5.4. So this is a checking step. Find the volume of the following pentagonal prism. Where A is the area of the base, okay, or the cross section. The first slice of bread or slice of cheese. Area times height. This area of 8 extends for 12. They're both the same units, meters squared meters. So you're 8 times 12. Put in your calculator. Next one, similar question. The cross section of this prism is shown in the diagram as a square. So this is a square. So the square formula is side times side. Side squared. We know for a fact the area is already 64. So 64 equals something squared. Well, if you know your square numbers, you know 8 times 8 is 64. If you didn't, just square root 64 in your calculator and you'll get 8. So I know for a fact that this is 8. So what I would do, I would have did it another way. I would have found out what this length is. Now that I know this is 8, I would tell myself 8 multiplied by what gives me 96, and that would be 12 here. And then I'd do 64 times 12 to give me my volume. But in fact, you can already do the question as it is here. Volume equals area times height. You have the area of this cross section 96, because you can use this cross section to find the area of this prism. The 96, that's the one face. This face here stretches for, or extends for 8 centimeters downwards. You can do it, or you can do it 64 times 12. But that would give you, that would make you do another step, and that would be to find what length this is. You should still get the same answer, so it really doesn't matter. And you can double check, so we could do 64 times 12, you get the same answer. Find the volume, calculate the volume. In cubic meters of the water trough below. It's in cubic meters, so you can kind of, if you read the question and you're aware of it, everything should be in meters. And I'm only saying that because I looked at the question, this is centimeters, centimeters, meters, meters. So you can either change everything to centimeters or every unit into meters. But the fact that the question wants the volume in meters, cubic meters, it's probably wise to change these two into meters. So this, 50 divided by 100. Divided by 100. 0.7. We use the formula. Volume is area of the trapezium face times by the height of 5. Area of trapezium is height over 2. Bracket 1 plus 0.7. It's just the area of the face. Volume is area times height. The height, or the length that it extends for, is 5. Find the capacity in liters. We established before. 1 cubic meter is equal to 1 kiloliter, which is 1,000 liters. So if I want to find this, you just take 2.1 multiplied by 1,000 to get the liters. So this you need to multiply by 1,000. Last question. Pretty tricky question. Tricky in the fact that the diagram is complicated. Not complicated in the maths that you actually have to do, because it's the same as what we've been doing for all these other questions for volume. The cross-sectional area is this face on the right here. So it's an awkward shape, so you need to divide it to this. Okay, so I'm gonna have to split. I'm gonna find the area of this face, which is in 3 parts. Okay, so A1. I'm just gonna write A1 here. A2 is the middle one. A3 is the bottom one. First area is a rectangle, so that's just base times height, or length times width. So base times height is, what's this length here? From here to here would be the same as there to there. 10 is that one. Times the height of it from here to here is the same as there to there. A2 equals a trapezium. Here to here was 10. Oh, we want to find the height first though, because the formula is half height. Okay, 5 is from here to here, so that means 5 will be from there to there. So 5 was from here to here. We knew this was 5 already, so 5 has to be from here to here. So 5 plus 5 is 10. 26 take away the 10 will give you 16. So the height is 16. A plus B, so the length from here to here is 10 plus, we know 28 is the full length. 6 is from here to here. So 28 take away 6. I think the answer was 256, but let me just double check. Yep. Area 3 equals this rectangle, 28 times 5. Same formula as that. can't remember this one. 40, that's right. So total. Add them all up. Then that total area, so this whole face here is 446. We multiply it by 25 because that face stretches or extends for 25 centimeters. Volume is area times height equals 446 times 25. Another way to do this question, which I'll cover, I've seen some of the students do it in class, which is another awesome way that I probably wouldn't do. Very interesting, is you'd find volume 1, volume 2, volume 3. So the only difference is every time volume 1, they would find the area of this face here, which is 10 by 5, and then they would find the volume for that whole section as well. So instead of breaking it up into areas, they're breaking up the whole shape into volumes. So they would do 10 times 5 for the area of the rectangle, then they times that by 25. And that, I think that is an awesome way. I just personally wouldn't do it. But you know me, in class, I do want to encourage you to do whatever way makes you the most comfortable. We already know the area of the trapezium is 256. We've done it here. So I'm just going to write 256 times 25 because even that section stretches for 25 centimeters as well. Drop a line there. V3. We knew 28 times 5 was 140, so they would times that by 25. Total volume, add them all up. You should get